Wait, can you hear me now? Can you hear me? Hello? Okay. Thank goodness, because this happened a few times. Like, okay. Good, good, good. I just exited YouTube and then opened it again. Look at how cute she's sleeping. Alright. So studying is actually fun when you know how to study. Thank you, thank you. If you have any exams, you got this too. Just gotta do your part and the ease will just come. Anyways, let's get back to studying. So the countries here are China, Bangladesh, Brazil, India, United States. We have all the information about those. And now it's formatted, so we have all capital, right? We have it structured the same. The surface area stayed the same, but the GDP, this one was billions, trillions, billions, trillions, 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 but now it's all in the same numbering format. Independence year, well, we only have the year here. We have the exact date here. We have only the years for some of them, so we add the entire thing. And then we have the languages, those stay the same. Percentages, they're all decimals now. So that's a nice example. So feature scaling in Zybo is converts numeric features to uniform ranges. Two common feature scaling methods are standardization and normalization. So feature scaling or like taking the z-score, standardization and normalization. Taking the norm. Have you done this before, Primo? Oh, welcome back, Antonio. Wow, nice to see you. You know, I always get surprised when people come back. Like it's really nice. But yeah, the z-score is something like you have to learn over the years, like constantly. It's like mean median mode is super common even for younger grades and stuff. Meow, yes, meow. Yeah, I remember, but at the same time I forgot. You're in 4th grade. Yeah. So have you done z-score before? That's called standardization. Z equals x minus mu all over sigma. And then normalization is the min and max scaling, converts features to the range 0 and 1. That's a little bit harder to remember. So n minus the min, and then the bottom is max minus min. So most z-scores fall between -2 and 2, and normalization is between 0 and 1. So when do we prefer one over the other? Standardization is usually preferred over normalization since it positions values relative to the mean and standard deviation. Normalization is useful when algorithms require all features on identical scales. So this is more preferred. But what about normalization? It's useful when you require all features on identical scales. Alright, and then standardization is best when outliers are present. Alright, standardized values are not skewed by outliers, but most normalized values are compressed into a small range. So only standardization likes outliers. And let's say, here's some examples. Assuming a car has a minimum of 500 pounds. You could try this one, Meow. I mean, not Meow. Meow, you could too, but Primo, I want you to try this. If a car has the weight minimum of 500 pounds and a maximum of 3,000 pounds, what is the normalized value of a car weighing 2,000 pounds? So using this formula, oh, the answer is already there. I didn't see that. Oh yeah, by the way, tomorrow is my science exam. 15% of my grade. 15%? That's a whole letter, bro. A letter and a half. So if you have like a, let's say 85, that would go down to a C. But if you have an 80, that'd go down to a D? Yeah, it would. Go from 80 to 65. That's crazy. But the whole entire grade or just, oh yeah, oh my gosh, overall, that's so scary. Hopefully you'll do okay. But it's impossible to get 0% on an exam, so you can't suffer too much. Even if you fail, get 50%. I think you'll be okay, but you never know. But my final today was 35% my grade. And it was bad. Alright, so x minus min. What is x here? It's 2,000. 2,000 minus the minimum is 500. So 2,000 minus 500 is, let's say, 1,500. And then the max is 3,000. 3,000 minus 2,000 is 1,000. So you have 1,500 over 1,000. 15 over 10. 3 over 2. No. 1,500 over 2,500. The minimum is 500. I don't know why I thought it was 200. Yeah, that's the car weight. Don't get that mixed up. It's easy to do these mistakes. So, yeah. 1,500 over 2,500. 10 over 2. 2 over 5. It's 0.6. Right? My mental math is so bad. No, that's 40. 1,500 over 2,500. 3 over 5. Yeah, now it makes sense. 60%. So assuming engine size is a minimum of 1.2 liters and a maximum of 6.4 liters, what is the normalized value of 3.5 liters? Alright, so without looking this time, even though some of it shows, you're super cold, Meow. Why don't you cover yourself with your wings, your owl wings? I keep on telling him to practice it, but he won't listen. Your partner is gonna follow me? Man, this is a universal problem. I literally had to do the same thing for my group, but I got too used to it. I don't even complain. I just do it myself, and thank God for ChatGPT. That's all I'm gonna say. So, let's do number 2. Assuming an engine size is a minimum of 1.2, so the min 1.2, the max 6.4, and the normalized value x here is 3.5. So the numerator, how do you calculate the numerator? So last time we did max minus x value. Or is that the denominator? No, it's x minus the min. Dang. Oh, I already forgot. So 3.5 minus 1.2. And only the bottom has the maximum. Because we want it to be a percentage, right? It can't be an, integer. So the bottom has to be a larger value. So the max, 1.2 minus the min, 6.4. So you get, let's say, 1.7 for the numerator. And then, 6.4 minus 1.2 for the denominator. Then you get 5.2. And when you turn that, and I think calculators are allowed for the exam, but the answer should be 0.44. Hello, Primal. Okay. So, unpacking data is a book. Some features encode multiple types of data as a single value. So, for an example, a part code feature may include characters that describe the part color. An overloaded feature encodes multiple types of data. I'm smart? I'm not smart. Honestly, like this is something that everybody has to do. They just have to study, but thank you anyways, Mel. I hope you study as well when you see me studying. You're smart for being here voluntarily. I'm not studying voluntarily. But I want to though. That's very nice. That's a very nice thing to be interested in. An overloaded feature encodes multiple types of data. A simple feature contains only one type of data. That's pretty straightforward. Overload is a lot. Simple is one. To simplify analysis, data encodes in an overloaded feature encoded in an overloaded feature should be extracted and stored as new, simple features. The overloaded feature usually remains in the dataset as reference information. So, the overloaded feature is actually the reference information. So if you have like an iceberg, for example, and you put it outside and it melts into water, that's a lot of droplets. But the iceberg is only one thing, right? That's the overloaded data, and each drop of water that drips from it or melts from it is the simple feature. And you have to extract that, and yeah, the rest remains as reference information. Very straightforward. Another example here. Considering to unpack VIN, if all information encoded in the VIN is unpacked, how many new features are added to the dataset? Let's see. This is your vehicle identification number. That's what VIN stands for. And it's your overloaded data and feature. So you have 1, 2, 3, 4, 5, 6, 7. 7 simple features, right? So the answer should be B. I don't think it should be more than 7 because, yeah, you have country, manufacturer, yes, overall 7 features. And then when the VIN is unpacked, is the original VIN feature retained in the database? Of course it is. That's your reference information, right? What, is that your homework? I already did all my homework, so I'm just studying. It's not really... I guess we could go over this afterwards, though. It's all participation. It's not homework at all. So, how should the model year be represented when unpacked as a new feature? The model year. Well, it should be expressed as the date time. It can't be the original code, right? Because that's not like unpacked, right? When you unpack something, you're kind of wrangling it, right? But yeah, it's definitely not the original code. But a year number derived from the code. But I mean, I guess that could be the answer as well, but date time is more better, right? Like the entire date, not just the year. But yeah, let's see. C, A, and C. That's my guess. You need to sleep? Okay, bye Primal, bye Meow. Thank you for staying. And the last answer was B actually. Oh my god. But yeah, have a good rest of your day, guys. Have a good sleep and bye. See you in my future streams, hopefully. So, how should the model year be represented when unpacked by a new feature? The model year code specifies a year only, not a full date. So, if this were to say model year, date, month, day, month, then yeah, it should say that. But a year number derived from the code is more better of an answer. So, if supported by the system, a year data type. So yeah, CAB. I think I was kind of thinking outside the box just because like date time was what the example. Anyways, let's continue. So structuring data, the Python language, and the pandas and sklearn packages have many data structuring methods. Selected methods and functions that format, scale, and unpack data are described in the tables below. So these are the packages, and these are the methods in the packages. But yeah, string, start, end. These don't have parameters, but returns the substring of the string that begins at the index and ends at the index and -1. So you never add the ending number. If you have like, let's say you have 0 to 5 here, you go 0, 1, 2, 3, 4, but you don't add 5 to the string. So that's where it ends. So this is a nice method here. String.capitalize. It's pretty straightforward, right? It just uppercase is everything. Returns a copy of the string with the initial case uppercase, initial character uppercase, all characters uppercase, all characters lowercase, or the initial character of all words uppercase. So string upper, string dot lower, string capitalize, string title. Those don't have parameters, but toDateTime has an argument parameter. So it converts argument to DataTime data type and returns the converted object. Data type of argument may be integer, float, string, DataTime, list, tuple, one-dimensional array, series, or data frame. So yeah, toNumeric, this argument converts argument. I think yeah, these are straightforward. DateTime returns the converted objects to all these things. Converts argument to data type data. DateTime data. And returns it to the converted object. toNumeric converts argument to numeric data type and returns the converted object. So this one is scalar, right? The numeric is a scalar now, which makes sense. Scalar is just a number, and numeric means number. So scalar, list, tuple, one-dimensional array, or series. You can't have. Oh yeah, you can't have series for the DateTime. But yeah, if there was like a matching in the exam, then this one is pretty simple. But before we go on, I want to make a quick to-do list, what we're going to study over. We have module 3, wrangling, part 1, part 2, module 4, Isaiah book, chapter 4, chapter 5, chapter 6, and then the Python code. Which is in module 1, Ringling, and something else. We have, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 things on the list. Alright, moving on, we have Pandas data structure methods. So data frame as type, data type copy equals true. So it converts the data type of all data frame columns to D type. To alter individual columns, specify D type as column, D type, column dot D type. D type copy equals true, that's your parameter. And then the data frame dot insert is lock column value. So if we should take notes on the data structure methods, then the first one that doesn't seem so straightforward is dataframe.sType. Colon, and your parameter is data type D type copy equals 2. And then data frame dot insert is to lock column value, and this converts the data type of all data frame columns to D type. To alter individual columns, specify and then for this one, inserts a new column with label column at location lock in data frame. Value is a scalar series or array of value for the new column. Inserts column. All right. So preprocessing.scale. These are the parameters. X-axis is 0 with mean equals true. Standard deviation equals true. The copy equals true. And then the description is standardized data in input X of data type array or data frame. Axis indicates whether to standardize along column 0 or row 1. With mean equals true centers the data at the mean value. With standard equals true scales the data so that 1 represents a standard deviation. That's a mouthful. But let's see. Preprocessing.scale simply standardized data in input X of array or data frame. Preprocessing scale just standardizes data in input X of data type array or data frame. Alright, and then the preprocessing min-max scalar to .fit transform normalizes data in input X data.feature range and copy our min-max scalar parameters. So this one standardizes .scale because it's like scale, S is close to Z and Z is standardizing, which is the Z score. And then this other thing just transforms it. It's actually normalizes it. So you're gonna transform into your best version. That's like the normal bare minimum person you should be. So cleaning data. Dirty data is raw data sets often containing missing, outlier, and duplicate data. I already went over that in the beginning. And missing data is an unknown or inapplicable value. So usually it's, not a number, not a time, null, or just an unspecified object or a blank value even. Outlier is just too large or too small. Duplicates are duplicates, common sense. And then they're all collectively called dirty data. We don't want them. Nobody wants these. A dirty instance and a dirty feature contain dirty data. So here's some missing values here. Missing inapplicable. This is an outlier. For sure, it's way different than all of these. And this is a duplicate. So this is dirty data right here. And then discarding that data, we remove it using, certain functions. Alright, so discarding instances, also called listwise deletion or complete case removal. So, pairwise discarding. Instance feature pairwise discard. So discarding instances. Listwise discarding features. Listwise or complete case removal. Removes dirty instances from the dataset. Dirty instances are usually discarded when dirty instances comprise a small percentage of the dataset. It's random or correlated with values in another feature. Discarding dirty instances introduces bias. Instances are duplicated. Usually duplicate instances are erroneous, and one instance should be discarded. Discarding dirty instances introduces bias. My pens are so bad. I need a whole new set. Honestly, let me get some watch time in. Oh, welcome. I was just studying, obviously. Yes. Let's go back to studying. So, discarding features removes dirty features that contain a high percentage of missing values. So if it has too many empty spaces, you just get rid of the whole feature itself. Just like we did with Antarctica in the continent thing. So this pen does not work. And then pairwise discarding retains dirty instances for some analyses and discards dirty instances for others. Instances are discarded only when analysis uses a dirty feature. So with pairwise discarding, the total number of instances varies for different analyses, which complicates comparisons and correlation. For this reason, pairwise discarding is not commonly used. Now this one is done. So it keeps some dirty analyses and it removes other ones. But they only do that because they want to see some comparisons or correlations. I don't know. That's why it's not normally used. It's kind of counterintuitive to do that. However, imputing data replaces missing and outlier data with new values. So you add, so imputing is kind of filling in the gap, right? So it's more complex than discarding because you're supposed to guess, right? And sometimes you just have to put the average, whatever the average is, but that could mess up your entire data set. So data may be imputed in several ways: hot deck and cold deck imputation. So what is hot deck? They both replace missing and outlier data with a value from a random selected instance. In hot deck, the value is selected from other instances in the same data set. In cold deck, the value is selected from a different data set. Oh, so it's a different data set for the cold one, same one for the hot one. But just from other instances. And then the mean imputation replaces missing and outlier data with the mean value of the feature. Mean imputation. Okay, that's what I was talking about. Sometimes you put in the average, and that's the mean here, right? Missing and outlier data are excluded from the computation of the mean. Oh, so you don't take the outlier here. Yeah, I guess that's self-explanatory. So we have 8 more slides for this one, and then we're done with that slide. I think the rest should be okay. Well, I think after each whole module, we should take like a 5-minute break and then come back. Because I'm going to be here the entire time. I'm going to be studying from right now. Well, it's been an hour. Started at 5:40. But now, I'm going to keep going until it's, let's see, 11 p.m. Alright. Regression imputation. Replaces missing and outlier data with a value computed from a regression model. Self-explanatory. In the regression model, the dependent variable is the dirty feature and the independent variable are other features. Yeah, I've been doing regression for the past couple finals. But that makes sense. The dependent variable is the dirty feature because that's what's changing all the time. But yeah. Stochastic regression imputation is what introduces uncertainty by adding or subtracting the regression variance to the new value. So you're like stoic, but you're uncertain, but you're stoic because you want to be calm, but everything is uncertain. You add and subtract the regression variance to the new value. Regression imputation is valuable if the dirty feature is highly correlated with other features. If not, mean imputation is commonly used. All right, and then regression imputation is valuable if the dirty feature is highly correlated with other features. If not, mean imputation is commonly used. Hot and cold deck imputation were common when less computer power was available to compute mean and regression, but are not widely used today. So those are the old methods. So here we have a dirty data set here. If you want to impute data for this one, St. Helena has a couple of empty data points here. But if you take the mean from all this, I mean, remove the outlier. Let's see, what's the outlier here? It's probably this one. So we only take the mean from these four. And then for this one, take the mean from here. Then what we get here is something else, but it's not going to show. Alright, with Python, 3 special symbols represent missing values. None represent any missing Python object, such as a string. So we have nan, not a number, is a numpy value, specified as numpy.nan. Nat is not a time, so it's a missing data type value, and that's pandas. NumPy, nan, pandas, nat. In addition, blank and 0 sometimes indicate a missing value and is as in any tool. So pandas for nat, NumPy for nan. So here's some other functions for Python when cleaning data. We have dataframe.drop, dataframe.drop duplicates. We drop anything that, a row or column that we don't need anymore. But this is only for duplicates. This is for just one value here. Removes a row or column containing missing values from data frame. Specifies labels on the opposite axis to consider for missing values. How indicates whether to drop the row or column, if any, or if all values are missing. So what is the difference between drop NA and just simply drop? So the label specifies the label of row or columns to drop, right? But this one is just the whole thing. His missing values. Come. Sometimes you gotta talk to them. Alright, have a seat now. It's study time. It's purring. He's literally Clifford in the cat form. Okay. Sorry about that. Can't really focus. But we're almost done, seems like. So, dataframe.fill NA, we just fill the missing values. So it replaces these values with value, which may be a scalar, dictionary series, or data frame. So it's pretty straightforward. This is for duplicate. This is for returns a Boolean series that identifies duplicate rows in data frame. So if it shows 1, then it was duplicated. So that's how you find duplicates. Sometimes it's easy to miss that with the human eye. And then this one. Alright, so dataframe.fill NA replaces NA and and then is null. There are no parameters here, but returns a data frame of Boolean values. True in the returned data frame indicates the corresponding value of the input data frame is none, NAT, or not a number. Okay, dataframe.mean returns the mean value of row access equals 0. Gotta do what you gotta do. Now I should have 2 constant viewers. Okay, got it. Perfect. More the merrier. I could do this again. Honestly, I have a lot of. Okay, now back to what we're doing. Good, good, good. So, returns dataframe.mean returns the mean value of rows of the data frame. Skip any indicates whether to exclude unknown values in the calculation. So numeric only indicates whether to exclude non-numeric rows or columns. And then to replaces values in the data set, data frame with values to replace, and value may be a string, dictionary, list, regression example, or other data types. So enriching data appending. Datasets can be enriched by appending new instances or features from external datasets. That's what we went over before. So to append instances, you have to prepare a subset of external data as follows. You identify it, and then you have matching features, and it must uniquely identify instances of both datasets. It has to be completely unique, otherwise you're going to get those duplicates and you have to clean that all over again. So usually only a subset of the external data set is of interest, so you don't want anything else, otherwise that's actually going to be counterproductive, you know, and you're going to have to clean that anyways, so there's no point in doing that. So you extract the subset and then you include the matching feature. Alright, and then continuing on with enriching data, so to append those instances, you have to insert the data subset instance to the original data set. So when you're trying to append it, you have to merge the subset with the original instance to match the features. You have to merge it, but how do you merge it? So appending data may create missing data, and yeah, you don't want to do that, but it does create two data sets with different features. But when you append the features, the missing data is created if instances of the two data sets do not match. So you discard or impute the missing data as described elsewhere in this material. Almost done. I don't know what he wants. What? So to derive data appending zybooks, a new feature can be derived from existing features in several ways. You calculate a new feature from one or more existing features. For example, you calculate a new feature as the logarithm of an existing feature. Logarithm or a ratio of an existing feature to another. So these are two ways of calculating features from existing features. It's getting a little bit complicated, I'm not gonna lie. So when you convert an existing categorical feature to a new numeric feature, what? Oh, and what is it, Yuki? What is it? What is it? Yeah. And then? What's wrong? He wants to cuddle, man. I ain't got time for that though. So, deriving data by appending zybooks. A new feature can be derived from existing features in several ways. I already said that, but categories such as heavyweight, lightweight, flyweight, numeric weight of participants in wrestling competitions. Got it. So when you're deriving data, Pandas may have data enriching methods, such selected methods, append and derive. So concatenating, applying, inserting, and merging. These are 4 methods of enriching data. So all these are data frame except for the first one that's concatenating with pandas. So in summary, data wrangling is a process of preparing source data for efficient and accurate analysis. Extract, transform, load ETL is a process that extracts data from transactional databases, transforms the data, and loads the data into an analytic data. ETL. ETL. That's more bougie. T in the middle. Sorry. Very sorry. So we're done with data wrangling. Now I have to go over data exploring. This is part 2 of data exploring. This one's a bit longer. It has 36 slides, but it's not too long. I don't know. I'm getting tired out here. This one is smaller. It's okay. This crash course is pretty big. I already studied this from before. We studied for 80 minutes. So I'm gonna do a Pomodoro. Oh my goodness. I was actually talking to myself this whole time. Dang, I forgot. I was like literally stoked when I saw you come back to the stream. I was like, dang, man, it's so nice to have you back on the stream, and yeah, I can't wait to be finished with this final, and yeah, like, and I really appreciate your comments. That's why. Can you hear me now though? Just want to make sure. So we have two data analysis tools here: Matplotlib and Seaborn. Yes. Okay. Perfect. Thank you. So, Matplotlib is a visualization library for Python that mimics the plotting syntax of MATLAB. And that's a whole different other software which I did use before to code in MATLAB language, but it's pretty hard. But these are Python codes, Python functions. So we use like other softwares like PyCharm or Jupyter. My professor uses Jupyter, but I prefer PyCharm just because like I already have it installed and stuff. But yeah, Matplotlib is a yeah. Uh, so this is how you install Matplotlib using this mpip install on the terminal, and then Seaborn is a visualization library that is built on Matplotlib. So Seaborn provides an easy-to-use interface to comment plots and supports pandas data structures. And each type of plot is called with a named function. The data frame and features to plot are passed as parameters. Seaborn can be installed using either the pip package manager or the conda package manager. To install Seaborn, simply use either of the commands below: pip install Seaborn, conda install Seaborn. Both Matplotlib and Seaborn are effective at creating visualizations that look clean. Alright, let's look at some of these visualizations here. So we have the simplest case for visualizations is a bar chart. A categorical feature divided the dataset into groups and categories. So a bar chart has groups on one axis and then rectangles with heights that represent the number of individuals in that group. So that's pretty straightforward. Next, we have a relative frequency bar chart. It's the same as a bar chart, but the height of each bar corresponds to the proportion of the dataset in each group. So relative frequency bar charts are useful when the proportion is more important than the count. So maybe it doesn't have that much in count, but in proportion, that matters more. So comparing between groups of different sizes here, we have California here. This is the pretty big proportion, but yeah, it's more important than the count. So a numerical feature. It contains numbers that vary over many values when visualizing a numerical feature. And this variation is the aspect that must be communicated. So several approaches to visualizing a numerical feature are listed below. So we have a histogram, a density plot, and a box plot. So bar chart. A histogram is a bar chart that is created by dividing the numerical feature into small regions and then counting the number of values in each region. And then a density plot is a plot that approximates the density function of the distribution for the feature and can be thought of as a smoothed histogram. Okay, so histogram kind of looks like the last thing that we saw, this bar chart here. But a density plot would be with just like a smooth curve going like that, like a little slope. And then a box plot, it's like the whisker plot, like a visual representation of the 5-number summary: minimum, first quartile, median, third quartile, and the maximum of a feature. So this is what the box plot looks like. This is not that does not look like a histogram. This looks like a histogram. But yeah, that's how you make it into a box plot, I guess. And here are some seaborn feature plots in Python. So we have the histoplot, we have the k-density plot, and then count plot, box plot, violin plot. So this hist plot creates a histogram of the named numerical feature from the data frame. This is for density plot, this is for bar chart, count plot is for bar chart. That's important because you think like the function is called bar chart plot or something, but it's just count plot or bar chart. Box plot is for the box plot. Violin plot, it creates a violin plot of the named numerical feature from the data frame. And we haven't seen a violin plot, but maybe they'll show that. Okay, so visualizing a single feature uses one axis to display the feature. Love your lives. Thank you so much, Bella. I love. No. Really? Can you hear me? Should I? Uh. Wait, no. Why would I type it? I could just. Okay, hold on. Let me refresh. Oh, wait. Okay. Hello. Can you hear me now? Testing. Can you hear me now? Hello. Testing. Man. Wait. Let me hear. Oh. I can hear it from my laptop. I guess it's probably yours or something. But yeah, I just want to say thank you for your support and your very nice comments. If you can hear me say them, but I really appreciate you even staying on the stream. So visualizing two numerical features. Oh yeah, we already went over this. So visualizing a single feature uses one axis to display the feature value and another axis to display the value's frequency. Alright, but visualizing more than one feature eliminates the axis to show frequency. So visualizing more than one feature should highlight the relationship between those features to be used in a model or when communicating to others. With two numerical features, the standard plot is a scatter plot. So a scatter plot displays an instance in a dataset as a point in a two-dimensional plane. The point's coordinates are the two features' values. So this is a scatter plot. There's only two features here, and when you plot it on the chart, you see the relationship they have, where they are in the plot. Hello, can you hear me now? I thought you had gone or left the stream. Well, not the stream, but like, because you couldn't hear me, but can you hear me now? So visualizing two categorical features, we have a stacked bar chart and a group bar chart. Oops. A plot of two categorical features gives more information by grouping one categorical feature according to a second categorical feature. So grouping male and female customers according to the day the customer visited. So a bar chart is created with one categorical feature. The second feature divides with color or shading each bar. The height of each piece is based on the number of instances with values matching the bar and shading. So a grouped bar chart is a bar that is created for each possible pair of values. The height of a bar is based on the number of instances with that pair of values. Bars are grouped by one variable and colored by the other variable. I think I already did that. Is this lagging? Okay, this is a stacked bar chart. So plot of two categorical features gives more information. I already read this, but so this is what it looks like. Grouped male and female, stacked bar chart. So let's see. This is the regular bar chart, right? We have about 18 yeses for smokers. Okay, this is not for male and female, but this is yes. On Thursday, we have 18 yeses for there being smokers. And we have around 45 non-smokers. And basically, you put the smaller one on top of the big one. So this one is 45. And then from 45 to 60, or maybe like 42 to 60, we have like 18. Yeah, that makes sense. This is 42, I guess. And yeah, that's how you read a stacked bar chart. Next, we have the commonly used plots for categorical features and numerical feature borrow heavily from scatter plots and single feature plots. So we have a strip plot, we have a swarm plot, overlapping density plot, a violin plot, which we have yet to see. I'm not sure what that exactly looks like. Side by side box plots. Oh, you can hear me now. Thank God, because I was like trying to put this here on the camera, and I was like, is he gonna answer? But yeah, I'm glad you can hear now. I think you're like one of my most loyal. Oh my gosh, Reels Brother Gaming, welcome to the stream. It's so nice seeing you guys back. It's more nice seeing like old streamers or like previous viewers than. Oh my gosh, no, it's okay. Some people, they just join once and then they leave, which I don't expect them to come back, but when you do, that just surprises me and like makes me happy. So thank you for that. Thank you for joining the stream again, guys. So a strip plot is what shows a scatter plot with points jittered off the line for the categorical feature. And jittering adjusts the horizontal or vertical position of points by small amounts so the points do not plot directly on top of each other. Okay, and the swarm plot is a scatter plot with points jittered off the line for the categorical feature so the points do not overlap. Same thing as the strip plot, except a swarm plot is useful for a small data set. But with an increasing number of points, the plot gets too wide. So swarm plot cannot take too many data points, but strip plot can. But yeah, honestly, they both take small amounts. It's kind of the same, but I guess the only difference here is that it gets too wide. And then an overlapping density plot is the numerical features Oh, how are you guys, by the way? Like, let me know how you guys are doing in the chat. Not like in the chat, but like how you guys are doing in real life. This is not just a study session, boys. To get to know you guys as well. How have I been? I've been good, thank you. I've been actually really good because I'm almost done with finals and I have a lot of plans after finals. I'm gonna start cooking again. I'm gonna clean my whole house, even though I'll always make my bed. Y'all don't see like the rest of my house. Like this room is always clean, but yeah. Thank you, Bella. But Bella, let me know more about yourself. Like, unless you're uncomfortable sharing anything, you don't have to answer. But like, how are you and like where you from? You know how to cook? That's awesome. What do you cook? Because I need to start cooking, man. I do not know what to cook. I just ate the last bit of leftovers we had, which was some tortellini pasta that my sister made. So, in an overlapping density plot, the numerical features distribution is plotted for each of the categorical features categories. Love my cats. Aw, thank you. Even though they're not here on the stream, we have like, they're usually here. Like, they always stick around in my room and watch me study. But yeah, I think they went downstairs to eat dinner, so they haven't come up since. All the density plots are plotted on the same axes with color used to differentiate categories. An overlapping density plot is useful for large datasets but does not display differences in the number of instances in each category. So, Violin plot is the density plot for numerical features. It's plotted for each of the categorical features categories. Each density plot is mirrored and plotted offset from the others. So that's useful for large datasets but do not display differences in number of instances in each category. How much time you stream a day? Okay, bye Bella. Have a nice rest of your day. Honestly, I stream whenever I study, just so that like I know how long I've studied for. Even though in that duration, I'm always like talking or playing with my cats or something. Most of the time, I would say in my streams I'm studying rather than talking. But yeah, I try to keep it as long as I'm studying. So yeah, I normally just end it and then start later. But today, I have to grind a lot because I have a final in less than 24 hours. It's at 11 a.m., but I have to leave the house at 10:30 a.m. So that's scary. Yeah. So Violin plot is useful for large datasets but do not display differences. So I think the last line is the most important part because most of these are similar. But let's write down some of these things. So swarm plot is useful. Jittering adjusts horizontal positions. Scatter plot with points jitter off the line. Where they okay. And then swarm plot. Useful for small data sets, but gets too wide. With yeah, I have a test tomorrow and I didn't study, I'm cooked. No! Whenever I stream, like you should be reminded that you have to study as well, if you have to study. But yeah. Just you could study alongside with me, just so you have an accountability partner. Let me know if you're studying. Like, what exam do you have tomorrow? So it gets too wide with large data sets. Man, these pens are so bad. I say this every stream. And then an overlapping density plot is useful for large datasets but do not display differences in number of instances in each category. Math? Out of all the subjects, you have a math test that you didn't study for. You have, let's say, trigonometry, geometry, algebra, all these things to study. If you need help with studying, I can help you. Filing plot is useful for large datasets. Each data plot is mirrored and plotted offset from the others. Mirrored density plot. Side-by-side box plots shows a single box plot of the numerical feature for each value of the categorical feature. Side-by-side ones are useful for condensing large data and looking for outliers. I'm looking for outliers. Yeah, but it's 11:08 and I sleep at 11:10, so I'm still cooked. Honestly, like 20 minutes of studying is better than zero. That's all I gotta say. I know it's not too motivational, but if you have to go to sleep but you're awake on your phone watching me study instead of you studying, then I don't know. That means you have the opportunity, you have the time, but it's, yeah, I get it. It's hard to study when your brain is not in the mode to study. So I guess my advice would be um unsolicited advice would be, if you go to sleep now, I think you could wake up in time for your exam, because if your exam's at what time is your exam, by the way? I didn't catch that. Visualizing more than two features. So faceting is the data divided into disjoint subsets. So most often by different levels of categorical variable. For each of the subsets of the data, the same plot type is rendered on the variables. Displays multiple plots side by side in an array where a categorical feature changes from plot to plot. Oh. Did you forget you had an exam, or was it on your mind but you just didn't want to study? Because I get it. Like sometimes, I remember at one point I didn't even realize I had an exam, and then I was so unprepared, but I still somehow passed the class. I don't know. It was biology. Okay, so you forgot, and that's first period, man. I'm really sorry. Like, you couldn't be more prepared, but I think you'll be okay. You said you were good at math, right? So you'll be fine, hopefully. So we have transparency, which is the point based on the value of a categorical or numerical feature, and then the color, shape, size, shading, animation. These are pretty simple. So here are some commands of Seaborn. We have the scatter plot for the horizontal and the vertical axes. We have the swarm plot, displaying the distribution of X for each group in Y. And then we have the strip plot, which displays the distribution of X for each group in Y. I studied 30 minutes, then I went to eat. I forgot I had a test. I went to church. I went back home. Then I forgot I had a test. Oh, wow. It was a busy day. Wait, I thought you go to church on Sundays. But isn't today Thursday? Oh, Oh shoot, wait, I have a class after this as well. So I have to stop the stream in like 47 minutes. As if the stream has not been going on long enough. But yeah, it seems like you had a productive day. You studied for 30 minutes, which is good. Then you went to church. That's good too. Oh, so you have church on Thursdays. I thought it was only Sundays, but yeah, honestly, more the merrier. Churches need to be used more often. So choosing base visualizations. So given a set feature, at least you studied for 30 minutes. That's good. I'm proud of you. So given a feature to visualize, the feature's level measurements determine most choices for which plot to use. But a data scientist should consider the audience and the story the plots tell. So simpler plots may be better than complex visualizations. For example, like bar charts. Those are better for um, non-data scientists compared to like stacked bars, which is a little harder to read for the inexperienced ones. Tuesdays, Thursdays, and Sundays. Wow. So where is this? Which country is this? Well, if you say it's 11, then that has to be North America, either Canada or America. But my guess is probably like Texas, right? Because 8:16 for me. I'm from California. So the norms of visualization choices vary based on audience. New Jersey. Wow. Nice. So, guidelines for selection plots. If both features are categorical, a bar chart is appropriate. That makes sense. There's two categorical variables here. Yes and no. If both are numerical, scatter plot. If one is categorical, one is numerical, then we have the density. But it's more like a line graph. And I don't know what this is. Word of warning, scales. So, scales should be clear to the viewer and not altered to accentuate differences in a misleading manner. By the way, Rios, if I'm keeping you up, okay, sorry, I got to go to sleep. Okay, I was just about to tell you, I was like, I would rather you go to sleep than watch my stream, even though yeah, I appreciate you being here, but yeah, good night. Bye, Rios. Hope you do well in your exam. So, scales should be clear to the viewer and not altered to accentuate differences in misleading manners. Manipulation of scales is most common when using bar charts. Bar charts should include the value 0 for bar length. Scales should also follow the conventions that up and to the right are the positive directions of the axes. Oh yeah, tell me when you were about to tell me. I don't know, I forgot what I was even saying, honestly. But yeah, honestly, I can't even remember. I was just saying good night. That's all. Colors. So they should contrast. If they're too similar, then it's not good. Color vision deficiency, CDV, occurs in 8% of males. Wow. I don't know why that is the case, but that does reduce the person's ability to distinguish between red and green. So, given the commonality of this deficiency, visualizations should be designed to accommodate for CVD by avoiding color that incorporates variations of red and green as the only distinguishing characteristics. You said, and by the way, Rios, then you read my comment. No, I honestly, yeah, I remember. I was gonna say like, you should go to sleep instead of watching my stream, even though I appreciate you being on the stream. That's exactly what I was gonna say. But then you said you had to go to sleep. I was like, yeah, that's good. But while saying that, I kept you up even longer, which is counterproductive. I'm almost done with this. I have like 16 slides left. It's pretty simple though. Like contrast, you have to have two colors, bright sunshine. Thank you. Thank you, Reels. Hope you do well in your exam tomorrow. Do not use rainbow scale. The contrast between colors in rainbow scales are not uniformly spaced, making distinguishing colors difficult for people with CVD. Bye. At this rate, you're gonna stay up all night. So, no rainbow scales, especially not red. Colors. So avoid colors that blend with the background. Use changes in other features such as size or shape. Okay. A pie chart is a circle made of wedges, one wedge for each group. The size of each wedge illustrates the proportions of the dataset in each group. Pie charts are aesthetically pleasing but do a terrible job of displaying information in an easy to understand way. Wow. How's this? I guess because it looks the same, huh? Yeah. These. I see. He will come by tomorrow. Okay, nice. I don't know if I'm really gonna stream tomorrow, but once I'm locked in for being a streamer, I think I'll still stream tomorrow. How long has this been going on? 2.5 hours of studying. Well, I don't think I'm studying for half of it, but it's good. Good progress. Okay. What is this? This is another one. Word of warning. Words of warning. Pie charts. Like for visualization. So performing exploratory data analysis. EDA is the process of investigating a dataset to understand what is the dataset. Exploratory data analysis. Okay. Identify relationships between the features. And then describe the shape of data. Number 4, we have detect outliers and missing data. So, find the size of the dataset, number of rows and columns. Identify and categorize the features, categorical and numerical. So this is positives, negatives, no correlation. This is symmetric. This is multimodal. This is skewed. Any model distribution deviation from the assumption can affect the model's validity. Determining the distribution's shape can confirm whether certain assumptions are satisfied. Alright, back to studying. So the pandas package has 3 functions in a data frame to aid with initial exploration of a feature in a data frame and numerical summaries of the features. We have shape, info, and describe. Pandas. exploratory data analysis in Python. The pandas package also contains several functions for visualizing all the features in a data frame at once. So in the table below, DF represents the data frame. Many relationship visualizations in pandas. So we have histogram with box plot, and we have plotting scatter matrix. PD plotting scatter matrix DF plots every pair of numerical features as individual scatter plot. For more control, Seaborn provides the function pair plot. Missing data. Sometimes datasets may have missing values, which can come from data entry issues, measurement issues, processing errors, which could be classified as missing complexity at random. So they have the same probability of being missing for all cases. For example, some participants may have missing laboratory values because of a batch of lab samples was processed improperly. So MCAR is equally all missing. Entry, measurement, and processing.
When did you give him food again?
Just before I came upstairs.
Oh. He doesn't want that one.
Oh yeah, he hates the healthy food. Mm.
Oh, you're...
Yeah. Always. Whenever I'm studying, I'm streaming. My stream was missing a cat. That's why no one's here.
You could do something.
Like, they're complimenting the cat before using it here.
Does it show the thingy? Because I just ate and I need to walk.
No, I could move it. I'm not leaving. Go back. So that's MCAR, right? Missing complexity at random. Missing at random has the same probability for a specific observable case. So MR were this pen is no good. This pen is no good. Man, how old are all these pens? Missing for all cases. And missing for specific observable cases. Missing not at random. So missing due to unknown reasons. So, an outlier is a data point that is separated from the rest of the data set. This separation can be in a single dimension or a combination of dimensions. So outliers have the potential to cause issues with models that use an average or similar function. Hence, identifying outliers is important for understanding the possible effects on resulting models. Cause issues. Outliers can have an oversized impact on statistics and models. The mean and standard deviations are subject to being affected by outliers. A linear model is subject to change for the values of an outlier. A high leverage point is an instance where an input value that is far out in at least one feature's distribution. And then an influential point is a high leverage point whose presence changes a model a lot. But not all high leverage points are influential. Alright, next. Parametric detection of outliers. So two easy to implement models of detecting outliers are Tukey's fences and z-scores. Often used to determine outliers in box plots. Tukey's fences.
Finally come to save me.
And z-scores. Interquartile range, Q3 minus Q1. And Z-scores value minus mean over standard deviation. Classify all points that have Z-scores of over 3 equals an outlier. God. So this is one in-class activity. A feature has a mean of 6 and a standard deviation of 3. What is the Z-score for the instance when the value 10.5? Should this value be classified as an outlier? So that's 4.5 over 3, which is 1.5 in total. What is the Z-score for the instance? It's 1.5, so if it's not greater than 3, so that has to be B. And then the first quartile of a feature is 3. And the third quartile is 7. So 7 minus 3 is 4. $14 is definitely an outlier. Because 1.5 plus 7 is 8.5. And 14 is way above that. Wait a minute. 1.5 times 7? Let's look back here. 1.5 times the IQR. So what is the IQR here? The interquartile range would be quartile 1 minus quartile 3, which is 4. So 7 plus 4 is 11. So yeah, that would be A. B and A. B and B? Okay, so 1.5 times 4 plus 7 is 13. Quartile 1 in this example is 3, quartile 3, 7, instance with the value 14 considered an outlier. IQR is equal to 7 minus 2 equals to 4 times 1.5 is 6 plus 7 6, 7, 13. So 14 is greater than 13. So yes, outlier. That makes sense now. It's good to have practiced this now. So dealing with outliers, you identify the cause to help an analyst know how to deal with outliers during data wrangling. Care should always be taken when dealing with outliers because some outliers occur naturally and some not automatically. So those ones we exclude. So energy produced from solar panels in the northern hemisphere is much higher in June than in December. It's not an outlier, it's just natural. And investigating outliers further is a good practice. So if there's no explanation, then you could probably... Oh, sorry. It should probably not be removed. Human error, correct that. Instrument error, remove the bias. Accident, remove the error. Error in combining data. Explore the dataset first, but don't remove it right away. But natural are not errors, so you should not remove that. And that's the whole thing. So, summary over what we did. Fundamental part of the data scientist toolkit is data visualization. Although it is very easy to create visualizations, it's much harder to produce good ones. Both Matplotlib and C4net are effective at creating visualizations that look clean. Visualizing a single feature uses one axis to display the feature value and another axis to display the value's frequency. But visualizing more than one feature eliminates the axis to show frequency, and linear relationships are the simplest types of relationships. And determining the distribution's shape can confirm whether certain assumptions are satisfied. Identifying the cause of an outlier helps an analyst know how to deal with outliers doing data ranking. That's it for module 3. This is module 4. And then we have Zybug and 3 other files of code. This is the outline, introduction. I could finish this, so I think I'll keep going. The data you need will often live in databases. Symptoms designed for efficiently storing and querying data. The bulk of these are relational databases such as PostgreSQL, MySQL, and SQL Server, which store data in tables and are typically queried using structured query language, SQL. So that's what it stands for. I think I'm done for today. Bye guys, I'm tired.